So, hello everyone. This is the first problem of today's Div 2. And in this problem, we are given that Alice and Bob came up with a rather strange game. They have an array of integers a1 to an. Alice chooses a certain integer k and tells it to the Bob. Then the following happens. Bob chooses two integers I and j and then finds the maximum among these integers, that is from ai to aj. Now, one thing to note here is I is less than j. Only this thing is important for this problem. And then we're given that if the obtained maximum is strictly greater than k, Elias wins, otherwise Bob wins. So we need to help Elias find the maximum k such that it is guaranteed that Elias will win. So first of all, just give me a second. Yes. So we are given that we have an array A and Elias will choose some number which is k, and then Bob will choose for this array A. Bob will choose two indices I and j, and among those, Bob will choose the maximum. And if Elias's k is less than, strictly less than all of these, the maximum of all of these, then Elias wins, otherwise Bob wins. So we want this to happen. So first of all, Bob will obviously, since Bob wants to win, he'll want opposite of this. So Bob will try to get his maximum as small as possible, right? So one of the ways to do that is he'll try to take the smallest subarray. Why? Like there is, if he wants the smallest maximum, he'll try to choose the subarray as small as possible, right? I hope nobody is having any doubt regarding this. So, and the smallest possible subarray size is 2. Why? Because I is less than j. So now, since Bob will try to get the smallest subarray size, which is of size 2, he'll always pick up this subarray only, like the subarray of having size 2. And now Alice wants an element which is less than the maximum of all of these. Like for all of these two length subarrays, there will be a maximum value, right? There are precisely n minus 1 subarrays. There are n minus 1 subarrays of length 2. For all of these, there will be some maximum, and Elice's value should be less than the minimum of these. Minimum of all of these maximums, right? Is this making sense? Yes, no? Okay, this is making sense. So that's it. Like we have to just do this thing, and that is our answer. So is anyone having any doubt? Minimum Elice's k will be less than minimum of these. Anyone having any doubt? I'll show you the implementation otherwise. Okay, so let me show you the implementation. So this is the implementation. I am taking all the numbers as input, and this is my final answer, count. So count is nothing but minimum of count and whatever the maximum of this is. Like this is the subarray xi and the previous element. I'm starting from 1, that's why xi minus 1. And minus 1. Why? Because I need less than this. Less than strictly, because it's written, it should be strictly less. So that's why count is minimum of these. Finally, I can print count. Is it clear? Like if it's clear, right? Yes. Otherwise, no. We'll move to the next problem. Okay, let's go to the next problem. Okay, in this problem, we're given that we have two distinct integers, a and non-negative integers, x and y. First of all, the thing to note in this problem is we have distinct. Okay. The second thing is like consider two infinite sequences a1 and a and b. A is defined as like an, like the nth term of a can be derived as n XOR x, and the nth term of b second sequence can be derived as n XOR y. X and y are given to us in the input. Now we need to find what is the maximum length of any subarray in these two which have the same values. So first of all, let's try to understand this problem. First sequence is given by this formula, I XOR x. This is the symbol that I'm using for XOR, okay? And the second is given by this thing. Now, first of all, why will these elements be ever same? If x and this is y, why will these be same? First of all, x is not equals to y. This is what is given in the first sentence of this problem, that both of these are distinct. So x is never equals to y. What happens if x is equals to y? Like what would happen if x is equals to y?
It will become infinite.
They both are infinite. Though both of them will be same. Both of the infinite sequences will be same. So there is no point in finding the solution to this, because like your answer would be infinite. So the second thing is, if x is not equals to y, why will these become like, while these two will become same? It's because it's quite possible that this is your first sequence, this is your second sequence. The values that appear at these three places is same as the values that are appearing at these three places. Note that it is not possible that your sequences will be like this, because if these two are equal and these two are equal, this simply means that what this means. X is equals to y, perfect. This means that your x and y are equal. Your two places elements cannot be same. So it's possible that they are equal at different places. Do you need an example? I take an example. Otherwise, if this is obvious, I'll move to the actual solution. Okay, let's take an example. See, your x is, let's say 3. In binary, this can be written as 1, 1. And let's say your y is 5. So if I take XOR with, let's say 10, whose binary is 1, 0, 1, 0, your 10 XOR 3 will give me 1, 0, 0. Now wait a minute. I'll take with 8 with this. And this is my, what is this value? 14, right? So if I take with 14, I'll get 1001. And if I take 14 XOR 5, I'll still get, no, just wait a second. If I take 14, I'll this will be this thing and this will be this thing. So these are not equal. These are not equal, right? 14 XOR 3 and 14 XOR 5 are not equal. Let's take some other value. Let's take 1. And so let's take what should I take? So I need, here I have a different bit and here I have a different bit. So eventually, if I need these to be same, is there any possible way to get these two same? Okay, let's change this. Like if this is like I don't like I said, since my x is not equals to y, I'm trying to get both of them equal by using the same value, 14. So if for using any value, I cannot get both, like using a single value, I cannot get both of these same, because that would mean that x is equals to y. So 14 is used for the first. What should be the second? Can anyone tell me if I need, like, what should I XOR with 5? So I get this thing. I should use, like in binary, I should use 1 0 1 1 1 0 1 0. Think I should use 10. Is it clear? What about others? So you see, my AI, like if my x was 3, my y was 5, my a 14 and my b 10 would be same. So my values can be same, but they won't be at the same indices, because if they are same, it would simply mean x is equals to y. So everybody, this thing is clear, right? They can be same, but not at the same place. Now, if they can be same, I have to find the longest subarray for which these are same. Is it clear? Subarray, not subsequence. Now, what we have to do, see, in binary, we are given something like, let's say this is the first value, and the second value is this thing. So if these two are same, tell me one thing. Like I'm XORing this with, let's say, alpha, and this would be something like beta. Beta is more than alpha. Like this is my 10, this is my 14, and this is my 10. This is my 10 in the earlier example. Okay. So I'm XORing the first thing with alpha, the second thing with beta. Next, I'll XOR this with alpha. Like my alpha XOR, this is my first number. Let's say this is my A. No, this is my X and this is my Y. So alpha XOR X is equals to beta XOR Y. My alpha XOR alpha plus 1 XOR X is equals to beta plus 1 XOR Y. And I have to find alpha plus n. This is the last element in this subarray, which is same. Alpha plus n XOR X is equals to beta plus n XOR Y. So the length of this sequence is n, like the subarray which is same, right? Yes, no? You're getting the idea, right? I have to find this n, this maximum n. Like my alpha XOR X is equals to beta XOR Y. Alpha in earlier example was, this was 10, and this was 14, and this was 10. So I have to find the maximum n for which this thing is equal. Like alpha plus 1 XOR X is equals to beta plus 1 XOR Y, like this way, right? So tell me one thing. If you see, if these two are equal and I have added plus 1 and these are also equal, this will simply mean that the both of these bits in X and Y are same. Why? Can anyone tell me why? Because whatever alpha, like if alpha is having the last bit unset, alpha plus 1 is also having the last bit as set. Like alpha and alpha plus 1 are having different set bits. Yes, no? Okay. Now, if alpha and alpha plus 1, whatever these, like this is like the second last bit, this bit, if it is set or unset in alpha plus 1, in alpha plus 2, it will be definitely different. Yes, no? Okay. Same thing goes for beta also. Like same thing. Like if last, whatever you are having in alpha plus 1, like the second last bit, it will be different in alpha plus 2. Like either it will be different than this or different than this. Last means least significant bit. This is the least significant bit. Okay. So now let's look at this place. If both of these are different, if you decide that, okay, in your alpha plus one, like in your, like whatever your alpha n is coming here, is having a set bit, then you will have a set bit here, right? Yes, no? And if you decide that your beta n will have beta n is having one, then you will have a zeroth bit here, or like it will be reversed basically. For one, it will be zero, for zero, it will be one, right? Now, in order to have both of these, like eventually you need, what do you want? Like if I'm saying that beta, whatever the beta is having at this place, like if it is set, the final beta XOR y will have unset bit at this place, or if it is set, like it will be unset. If it is unset, it will be set in XOR result at this place, right? Like, what do you mean by no? Like someone said direct. Like Deepak, like replied to me that no. Like, what do you mean by no? Like one XOR one is zero and one XOR zero is one. So if this is your bit, like this is currently, if one is the bit in at this place, if in beta it's one, you'll get zero. If it is zero, you'll get one. So I'm saying this thing reverse. And for alpha, it will be same, right? Right? Yes, no. For alpha, since the bit is unset. So the first place at which your bit is different, that basically means that at that point you'll get the first place at which you have these bits as different. You will start to see discrepancies. How? See, before this point, you will try to have all the things same. So if the bits are different, if you have 1 1 0 1 0 1 0 and you have one, so this is the first place at which your bits are different. Before this, it doesn't matter, right? And eventually you want alpha XOR this thing and beta XOR this thing to be same, right? Alpha beta can be anything. So alpha and beta for these places, you can like make accordingly. Like these doesn't matter, like the values which are before. Only this thing matters. And after this, you have free. Like you will try each and every possibility. Only this thing will matter, this thing. And before this it's same. So basically alpha here will be, oh, you can keep 1 1 no matter, like eventually you'll get 0, and beta can be 1 and 0 at these places. Like this is beta and this is alpha. So I'm basically getting the starting bits 0 in both in the XOR result. And for these, if you try to keep set, like if you try to keep set bits, you'll have a 1 here and a 0 here. And other than these, you'll try each and every possibility. So how many possibilities? Two possibilities for here, two possibilities for here, two possibilities for here, two possibilities for here. Why two possibilities? Like you can keep a 0 or 1 here, 0 or 1. Like accordingly, you'll have a 0 1 here. Like same 0 1, same 0 1. Like if you decide 0 here, you'll have 0 here. If you decide 1 here, you'll have a 1 here. So basically, it is 2 to the power 4. Like why? Whatever you have here, like if you decide that you will have in this place, you'll have a 0 1 1 0. Here also you'll get 0 1 0 1 1 0, and you can take XOR, these two XOR and these two XOR, you'll get the same thing. Otherwise, maybe you can have a 0 here and a 0. Again, you'll get the same XOR. Basically, the last four places can have any bit. either 0 or 1. Why? Because the bits in these are same. But you'll have to, in order to keep them same, you'll have to have these kind of arrangement. Once you are done with these four, like what the last thing here you can have is 1 1 1 1 1. After this point, this will become 0. And at that point, your alpha XOR this and beta XOR this condition will break. Is it making sense now? Basically, all the last bits which are same, those can be anything in alpha and beta. So you basically have 2 to the power x if x is the common, like the same bits at the last. Why last two bits are kept same? Where? Like, can you unmute yourself? Like, it's really hard for me to explain if I don't understand the problem. Like, where I have kept the last bit same. And first of all, don't reply to me directly. Like, don't ask your question publicly so that everyone can get an idea what you're asking, like what I'm replying to. Like, how it is, like, you cannot, this is basically how will this give us the largest subarray? Because basically after this point you cannot take, like, the next bit cannot be anything. Like, you can have anything in this part. We are going in, like, we are first finding AI is I XOR X. So I is going subsequently. So after you have 1 1 1 here, the next thing will be all of these will be 0 and this will change. So at that point your subarrays won't be same. Yes, because we cannot make the digits equal. So that's why this is the maximum. Anything else?
Can you once just brief it, please? Like, I just lost track of it in middle.
So first of all, this is simple XOR operations that you should know. Like, if you are doing 1 XOR 1, you'll get 0. 1 XOR 0 is 1. Now, the first place at which these bits are equal, since x is not equals to y, you cannot have, like, in order to get all the, like, before this, you can have anything. After this point, you'll have some adjustments made. Like, if they are same, okay, you can have anything in alpha, anything same thing in beta. Otherwise, if one bit is set and the another one is unset, then alpha XOR X, you'll decide whether the result will have set or unset. If it is having set, you'll accordingly have that bit set or unset in alpha and accordingly have the opposite in beta. So after this point, you have some kind of, like, it's decided upon the result. But before this point, you can have anything in alpha. And the same thing, like, why? Because since each of these is same. So the first time you get the foundation is this place when the bits are different. Before this point, you can have any of the two bits, like either 0 1 here, 0 1 here, 0 1 here. So 2 to the power x, where x is the number of positions which have the same bit from last.
Okay, got it. But like, how to get intuition of this type?
How, like,
Intuition.
oh my God, you'll have to, like,
But
solve
also
problems.
like, yeah, I got it. But how can you tell, like, for alpha plus 1, alpha plus x, till how many numbers that are same? So like,
Yes,
if
how many numbers are same? Because, like I
two,
said, the last, these are equal. So these three places up, like,
okay,
8 numbers will be same. Why? Because there are 8 options here available.
8 or 7, 7, I guess, right?
7, 7, not 8.
Maximum. Yeah,
No, no,
7,
no,
no?
8, 8. You have 0, 0, 0 also, right? 8 to the power 3.
Acha, acha, okay, okay, okay. So like, till that point,
Yeah, if you
but
decide 0, 0, 0, or both will be same. All the way up till 1, 1, 1. 8 options, not 7.
yeah, okay.
So,
And after that point, like, can't we make anything like to make them similar?
like, try like, this will be like much clearer if you try, like, take two numbers and see. Like, I can, like, I have already shown this, but like, you'll get a better intuition if you try to make these equal. Like, let's say these are different, all these three positions are same, doesn't matter. Try to make these same. You will see that if you try to make these same, you cannot make these same at the same time. Like this will be like, because you have already made these same, this is alpha plus something x, like not, let's not take x, let's say alpha
But
plus c,
bits
and this is also
like
beta plus c. This has to be same, right? C, because of this they won't be equal. Like you won't get, you will get, you cannot make this unset and this also unset at the same time.
one question I have, like every
Why you
bits are
cannot? Well, let me
every
explain why you cannot, because you have 0 0 0, you have already made this thing, then like two options for everything. So lastly, you what option would you have? You will have 1 1 1 here and 1 1 1 here, right? Last thing for which these are same. The next will be, there will be zeros for these and one will come here, technically. And there will be zeros here and one will come here, right? Yes, no?
yeah, yeah, yeah.
So this will
Okay.
also change, this will also change, this will become unset, this will become set. So XOR will have this bit different. Yes, you were asking
Oh,
something.
yeah. No, no. I was about to ask, like, okay, when there are ones both above, so like why we can't set them as same?
Why, if,
Like you are telling, right, till this point they are same, so in that point you are telling we can treat all the bits independently, right? So that's what my doubt was. Like we treat like that only when we are doing any bit manipulation question, all the bits independent,
but
something like.
eventually you have to make alpha XOR X equals to beta, like beta XOR Y, right?
Yeah, yeah, okay.
So you, like, even if you are trying to keep them independent, alpha, like you have to have like next number in the series, right? Because sub array
Yeah,
should be, so you cannot have like like at suddenly you cannot decide that okay, this bit will be unset or this bit will be set. Try to take the next
yeah,
number.
okay,
Like if you are having here 10, like whatever, like you will have the next number 11. So that's why it will break. Not because like you cannot just directly jump to some other number and say like, okay, the next number will be this, from which I'll take the XOR. Like right now
okay.
you are
So
just trying to fit like for this and this. You're saying that I'll take independently. But eventually, if you're taking XOR of this with, like you started with 4 here and started with 7 here, this will be like 4 plus 8. So you will take XOR of this with 4 plus 8. It's decided, and 7 plus 8. This is also decided. So they are not independent like that, that you can take any way to fit these two bits.
okay, 4 plus 8 and 7, something you were telling, like
Yes.
let's say you have set those three bits in both the numbers, and next you are trying to set like, can you give me one counter example where you cannot set them, something like that, so it would be more clear.
Let's take one.
One counter example
12 and
where you cannot fit it.
4. So what is the bitwise XOR of like binary representation of 12?
1100.
And what is for 4?
It is 100.
100.
Yeah.
So what is the first place at which these are different?
Fourth bit, at the
Let's
fourth
see.
bit.
Now, what were you saying?
I was telling, like, at somehow can we make why can't we make them
Okay,
same?
like for that, you'll have to write XOR. Like try to write XOR of this from one. Like what is 1 XOR 12?
One
13.
XOR 12 is
12 is
13. Yeah.
14. Then like you write it like this and you'll see why you cannot, like the maximum is 8,
Okay.
because these are same. You can have anything here, anything here, anything here. And before that, you have already tried to fix these. But
Okay. So
see, like I'll have to okay, how many people have the same doubt? Otherwise, I'll take this, like I'll have to compute this. I think it will come up around 20. I'm not completely sure. If 5 or 7 students have the same doubt, I'll pick this right now. Otherwise, I'll pick this after the PCD. No one.
can explain it. Three people are there, including me.
Yes,
once
I'll take this, like I'll explain this after the PCD.
yeah, okay.
Like if you want, meanwhile, you can just write the XOR of these. Like do one thing, just write the
Uh,
XOR of this. Like it will take a little bit time, 13, 14. What is 12 XOR 3, 12 XOR 4? Just write up till 20 and you'll see that why this bit is you cannot keep same. Just write up till 20, okay?
okay, okay,
If
okay,
you're able to write this correctly, you'll get Y.
okay.
Still, don't worry. I'll like maybe once after the contest, I'll calculate
Yeah,
this along with you.
yeah,
Okay.
yeah, okay, okay. Thank you.
No, no, it's okay. You don't have to thank me. So the solution is this thing. See, first we are given. I'm sorry, like this took way too much time. Like this problem. So we have x and y, and we take x and y as an input. Then I have created two vectors to keep the binary representation of those. Like what is the first bit, what is the second bit. So this is how we calculate the binary representation. At last, till like one of these is having less size, like what I did here. After writing binary representation of 4, I added a 0 in front of it, right? This 0. Why? Just to make both of these of size 4. Both of these of size 4. So after I have that, I'm just checking while both of these bits are same. I'm multiplying my, because for those I have two possibilities, either 0 or 1. I'm multiplying my answer by 2. Otherwise, I'm breaking. Finally, I can print my answer. So, anyone having any doubt regarding the implementation? Okay, let's go to the next problem. I'm sorry, I'll rush a little bit now because we have already wasted a lot of time. But in case you have doubts, like feel free to ask. Like I won't skip any doubt. Yes, we'll cover D. So the third problem is we have been offered to play a game. In this game, there are n possible outcomes, and for each of them, you must bet a certain integer amount of coins, and in the event that is the ith outcome turns out to be winning, you will receive back the amount of coins equal to your bet on that outcome. Multiply the ki multiplied with by ki, and note that exactly one of the n outcomes will be winning, so all the remaining will be losing outcomes. So your task is to determine how to distribute the coins in such a way that no matter what, you'll always get more number of coins than you initially placed on bet. So this is important that the number of outcomes is between 1 and 50, and the number of coins is everyone like every for every outcome, ki is between 2 to 20. So first of all, let me explain the problem statement. Like this problem seems a little like, I'm not sure, like it seems so difficult, but the solution is rather like it's, I don't know, like once you know it, like it seems a little bit obvious. So we are given that there are n outcomes. These are all the outcomes. One of these is like randomly, it can be anything. And for each, we are given a ki. So we are asked to place coins on all of these. Like how much we'll bet on this, how much we'll bet on this, how much we'll bet on this, how much we'll bet on this. And if we decided, okay, I'll bet alpha on this, beta on this, gamma on this, delta on this, eta on this, theta on this, and something on this. So sigma on this. So now if this is the case, if this is the outcome that is like winning, like this is the winning outcome, I'll get specifically delta times ki coins, like with whatever this ki is, k4, and how many coins would I have bet? I had bet alpha plus beta plus gamma plus delta plus eta plus theta plus sigma. Right? Yes, no? So I want this thing, basically this variable multiplied by ki more than this thing. This is fixed. The number of coins that I'm placing is fixed, but I want this to be more than everything else. Like if every time I want this more. Yes, no? Now, how many of you have solved this problem? Like I want to hear your approach. Like I'm not sure like whatever came to my mind, like I don't know if it's generic or it's like how did you solve?
Am
Like
I
you can
audible?
unmute yourself if you want.
Am I audible?
Yes, yes.
Yeah, so I just took LCM of the array and subtracted one and checked if it works. If it works, then it's yes, else it's no.
Like why LCM?
Because it's the smallest number. Like if you do LCM minus one, it's the smallest number such that the product will be greater.
So LCM is also more. LCM plus one is also more.
No, that's why it's LCM minus one is the smallest number.
Which
Like
is
for example, there was one case of I think
LCM minus one is the smallest number, which is
such that if when you multiply it by the divided by that array I and then plus one, then it's greater than the number of coins. If
yes.
LCM minus one is your original number of coins.
LCM minus one is your original LCM minus LCM of these LCM of these, right?
LCM of the entire array, yes.
Yes, this LCM of all of these is more than okay. Yes, I did also the same thing, but like once you know this, it seems obvious, but like to get to this point is hard. See, and by the way, LCM minus one, LCM anything would go. See, the point is as long as you get this point that LCM of these, if you take LCM of these, how many points? And like let's say I'll eventually if I win, I want LCM of these as my returning coins. Like if I win in any of these, I want LCM of these as my coins. If this LCM turns out to be less than the sum, my answer is no. Why? Can anyone explain me why? Why if LCM is less than LCM of these is less than the total or sum of these coins? Can you tell me why?
Can you repeat?
Like why if LCM is less than the sum of these coins, my answer is not possible. Always. Like I just have to prove this thing. If my LCM is less than the sum of these coins, my answer is never possible.
Coins as in KIs.
Yes, KIs, I'm sorry. If my LCM of these values, if these KIs of these multipliers is less than the sum of these multipliers, my answer is never possible. If you're able to prove this, then the problem is solved. Why? Okay, let me explain why. See, my question is, if my LCM of K1 to Kn is less than the sum of the coins that I have, my answer is not possible. Sum of coins that I have invested. Like I didn't get minimum. We will take one as alpha. What do you mean by this? See, I'll tell you. If you have LCM as your coins, so for each you are taking LCM. For each you are getting LCM. So alpha, like alpha, beta, gamma. Like let's take an example. So let's say I have 732 multipliers. What is the LCM of these? 42. So I want LCM as the number of coins returned to me. So 7 divided by 42, 6, 14, 21. So I'll bet 21 coins on these, 14 coins on this, 6 coins on these. What is the sum of these? 41. So for this, it works. Now let's take another example, 2, 2, 2. What is the LCM? 2. Right? So for this, I'll bet 1 coin, 1 coin, 1 coin. How many coins did I bet? In total, 3. How many coins did I receive back? If any of these was winning, I get 2. So 2 is less than 3. I invested more and I received back less. So this is the losing state. Now let's try to like how will you make this better? How will you make this better? Now you might say I'll invest 2 here. So this is a losing state. You will say that okay, I'll invest 2 here also, then this becomes a losing state. So you'll say I'll invest 2 here. Back we are at the same point that we are getting 4 coins and we have invested 6 coins. So no matter how many, like if you increase any of the increase for any situation, you increase the or for any outcome, you increase the number of coins on the bet, the other will become a losing. So this will always happen. So that's why if at initially your LCM is less than the number of coins that you are betting, total number of coins, then it's always a lost. Like you'll never be able to get more number of points in return. Otherwise, you can simply do this, find the LCM, and for every situation, for every outcome, just try to get these number of points in return. So how to do that? LCM divided by the multiplier. Invest that many points. Is it clear?
Yeah, it is clear, but can you please tell the intuition of this?
Like how did I get to this part?
Yeah, yeah. So,
Because see, first of all, I tried to see like how can, like for every outcome, I try to in return, let's try to get a fixed number of points. I always want that much, not less than. And the second thing is, I just tried to see this thing too if the values are same or like in input it was given 555. So no matter if you invest more on one, the second one will become losing. Like you'll never be able to if that like that is the winning outcome, you'll never be able to get your coins back. Otherwise, if you make both these same, then both are and like from both you cannot get coins back. And if you
no,
increase
no. This thing is clear, but I'm asking about intuition, like how to reach to that point, that one.
yes, so
Uh,
like usually like see 30% of the times like at start, once you start to go like this problem, like this is like usually I code these problems like without any proof. And like if it passes, it's good to go. If it not passes, try something other. So for this problem, I also think like this is and for like if you want the real proof, like I think it would be like much clearer or much better in the editorial. I think they might like that's why I started this problem with like how many of the you solve this problem. I think all the people who are like who solve this problem using LCM did the same thing. Like just first try to fit with LCM, then they try to check what if LCM is less than it, and the original problem editorial might not be using LCM even at all. And like how like because I have solved problems like this, and once I did the problem, like I said, 30% of the times I just start to code, try to submit it, try to like first I try to work with some edge cases. If it's working, I try to submit. If it works, good to go. Otherwise, like then I'll try to change the idea, like might change my idea.
yeah, okay.
So there are other questions. Like it's basically first you try to say that okay, this is my solution, this is the maximum number of points I'll get, and then from there start in reverse. Like okay, then how many coins do I need to have each? And once I've decided on the number of coins, then try to find the sum and then check whether the total number of coins that you get is always more than the number of points that you are investing, rather than starting in like from this that okay, first give the coins, like start from the number of coins given, then find how many coins you're getting from each outcome in return and then checking. So anyway, let me show you the implementation. So this is the implementation I have taken in as input. Then I'm going through this. I'm taking the input and calculating the LCM. This is my global function. I don't have it here, but this is basically I'm calculating this using GCD x multiplied by this divided by GCD of x and v. GCD is STD function. Like you can get GCD, you can write your own also, but you can get from GCD like STD also. By the way, LCM is also I think defined in from C++ 20 or maybe C++17. I'm not sure. So then I calculate like for each, I'll get these many coins. It's 0. AI is X divided by VI. X is your LCM divided by VI. Basically, AI times VI, like this is AI is the number of coins you're betting on ith outcome, and VI is the multiplier. So AI times VI is always equals to LCM. Just find that, okay, if sum of all the coins that you are betting is more than the number of coins that you're getting, then simply the answer is -1. Otherwise, you can print the number of coins. And this should be equals to. Is it clear? Yes, no? Okay. Let's go to the fourth problem. Like today's session is, I don't know, like it's already 1 hour. But anyway, let's cover this problem. So you are given a binary string S of length n consisting of zeros and ones, and you can perform the following operation exactly once. The operation is choose an integer p. I'll explain this in the writing board. I'll explain this here. So you have a string S. You first choose p, then you reverse it, and then one by one you place these characters in cyclic order at the last. So instead of doing this, this is the first character, second, third, fourth, all the way up till n. What you are doing, you have this 1, 2, 3. Just place this 3 here, this 2 after this 1 after this. So from 4 to n and 3 to 1. This is what you get. So this is the operation. This is the operation if p is 3. So I think the operation is clear. This is the long problem statement that is given. Just this thing, like the fourth character till nth character, then third, second, and first character. So this is the third op, like p is equals to 3 operation. Then we are given k proper. What is a k proper string? Again, we are given some complex thing. In brief, we are given it should be the first k character should be same. Then the next k characters shouldn't be equals to any of these, but they should also be same in a way. Why? Like, let me show you the problem statement. Like we can derive this. Like k proper is S1 to Sk is equal and Si plus k is not equals to Si. So for any I from 1 to n minus k. So see, let's say this is my string. K proper is, let's say the k is 3. So all of these are equal. S1, S2, S3. S4 is not equals to this. S5 is not equals to this. S6 is not equals to this. So this is all zeros. So this is 1 not equal, not equal, not equal. So in a way, these three are equal. These three are equal but different. These three same will be equal but different. Did you get my point? So this is K proper string. Is it making sense? What about others? So I have simplified the problem. What is a P operation we know, and what is a K proper state string? Is it clear? Now we have to find what is a P that we can use, like a P operation that we can do exactly once to make this string K proper. Even if the string is earlier K proper, we have to do this operation exactly once. So what we are doing, see, we are removing these characters and keeping them at the last, right? So let me write the original. So original is 1, 2, 3, 4, all the way up till n. If I do p equals to 1 operation, I'll get 2, 3, 4, all the way up till n and 1. If I do p2 operation, I'll get 3, 4, all the way up till n and 2 and 1. If I do p equals to 4 operation, I'll get p4 up till n and 3, 2, 1. Is this thing making sense? And out of all of these up till n, I need to check whether any of these is k proper. Yes, no? So what can be a potential P? See, there are two. Oh, there is one simple solution, but for that you'll have to know string hashing. I'll discuss that also, because like anyone can solve this using. I'll discuss string hashing solution also. But first of all, what is a P that you can choose? What is one of the P's that you can choose? Like, what should be your P? If you have to find a P, if you start from the start of the string and you find that this character and the next character are not same, what will you do? If this character and the next character is not same, then what? If this character and the next character is not same, and you are not at a breakpoint of k, then it simply means that you have to do something. See, try to understand that. Let's say your k is 3, k is 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up till end. Your k is 5, and you find that okay, this and this are not same. So in your k proper, you need this in different bucket and this in part in different bucket. Is this making sense? First of all, you need to have these two in different buckets. By bucket, I mean if the k proper substring, this will be like kk buckets, like k length buckets. So all of these are same. Internally, they are same, but with respect to each other, they are different. Like one is having zeros, another one is having one. So if you find this thing that, okay, for the first time, you're getting that in this k length bucket, these two characters are different. So you need to have these two in different buckets. Is it making sense this much? Like if this thing is not making sense, let me, like, I'll repeat, otherwise like there is no point going forward. Okay, if this thing is making sense, now let's suppose I never found that this scenario, then what is my answer? I'll repeat once more. Let's say these are my string characters, S1, S2, S3, S4, all the way up till Sn. I have k is equals to 5. Like, what does this mean? This means that all of these should be either 0, 0, 0, 0, 0. Then these should be 1, 1, 1, 1, 1. Then next should be 0, 0, 0, 0, like this. But I found that these two characters are different. Now, no matter what, I need this part and this part in different of these buckets. I'm calling this as my bucket, either zeros bucket, one bucket, alternating. So I want these in different parts because this is 0 and this is 1. No, like these cannot be in same, right? Yes, no. So this is my one of the, this has to be P. This has to be different. Like what is the pth operation? I'll just shift this at the last. So S4 to Sn and S3, S2, S1. Otherwise, other than this, you choose anything else. These will be in the same bucket because K is a multiple of P. You choose something big, something small. These S3 and S4 will always be in the same bucket. You can choose anything else. Choose anything else. S3 and S4 will be neighbor of each other. choose anything else. Choose anything less, you'll get S3, S4 in the same next to each other. Choose anything big, S3, S4 will be same next to each other. So you have to choose P as this thing. Is this thing making sense? Like you have to write yes, right? If earlier you had doubt and it is cleared, you have like write yes. Otherwise, okay. Now let's say if I iterated through the complete string and I never found that in a bucket, two of these are different. Why it cannot be bigger? Like try to take bigger. S1, S2, S3, Sn. S3 and S4 are different, and your length of K was 5, and you decided to choose 6 or anything more than 3. Let's take 4. Let's take 4. Let's take 4. Okay, S3 and S4 were different. So what will happen? You'll get a new string which is S5 to Sn, S4, S3, S2, S1. K is 4. Still, these are in the same bucket. You choose anything big also, last, these two will be in the same only. If you would have taken 5 length, then S5 will also come here. Eventually, these two will be same only. The bucket is of 5 length. If K was 3, then though there is no issue na, if these two are different. Then though it's completely fine. They are not in the same bucket. But if S3 and S4 are in the same bucket and then they are different, then it is a problem. And okay, right now I'm moving ahead. If you have, like, let's discuss this afterwards. I think we have like, we don't have like unlimited amount of time. But this is like really basic. If S3 and S4 are in the same bucket, that is in the K length buckets, and they are different, then we have to choose P as that. Now, if we never find this kind of thing, then our answer always exists, and we can take complete string. P is equals to complete N. Nothing changes. We can simply print it. Otherwise, we have some P, right? And that P is, if that P is the last character, if that P is the last character, then our answer is not possible. Why? Because if the last character Sn, you will keep S minus 1 here. Earlier S minus 1 was here. You will keep all of these characters, you'll bring it here. Still they are neighboring. Earlier they were neighboring, now they are also neighboring. So in that case, the answer doesn't exist if your P is the last character. Otherwise, if your P is something before it, your answer exists. So how to check? Just do the operation, what is asked, and check whether your answer is there or not, whether your string, because you have to do this operation. Otherwise, as whatever your characters were different, you have to choose this. So once you choose as this P, suppose S1 to SP, and this is SP plus 1 to SN, just bring these character at last. So SP plus 1 all the way up till SN, then SP minus 1 all the way up till S1. So just check whether this string is K proper or not. This is simple. If this is true, then your answer is yes. Otherwise, your answer is no. And for yes, your answer is P. Whatever P we had chosen initially. How did we get this P? We get this P from initially matching all K buckets. And if there are two places in a bucket which are having different values. So let me show you the implementation. So first we have taken input, and then initially let's say that my P is -1. For counting, I have like how many characters I have in a bucket, like K. So for counting that, I'm counting that how many characters I have same. And if the two characters are not equal, then I would say I need to break here. Okay. Otherwise, like once I have found P, I will say that if I never found P, my answer is N. Otherwise, if my P is N minus 1, answer is not possible. Otherwise, I'm applying the operation P equals to N operation, P equals to whatever the P operation is. Reverse this part. Like this is one of the ways to do it. Reverse this part. Like find the substring of this part, find the substring of this part, and insert this part at the end of this part after reversing it. This is the new string. check on whether it is a K proper or not. If it is a K proper, we can say that, okay, P plus 1 is our answer. Why P plus 1? Because P started from 0. P is started from 0. Like P is 0 index. So we can say P is our answer. And how we are checking that it's a K proper? Just check whether if these two are not different, it has to be K. Otherwise, if like it's a K bucket, so then it's okay that these two are not equal. For K length substring, they have to be equal. Now I'll look at the dots. So this thing is clear, right? Why P cannot be bigger. Okay, string hashing method. String hashing method is very simple. If like first of all, if you know string hashing, it's basically how to match two characters, like two substrings, like two strings basically. So if you calculate string hashing of the complete like string, and you know that method that using any, like if you have prefix hash, you can calculate substring of any substring. So similarly, calculate prefix hash and suffix hash and iterate from 0 to n minus 1. That is from left to right, and try to take the starting substring as your P, like P length substring as your string for this operation. K is fixed, so you can just check whether it's satisfied. Like it's kind of brute force, but the code would be long. Like what is the issue with 0, 1, 1, 0, 2, 1, 0, 0? If K is 2 and you have this string, first of all, is answer possible for this? Well, like, like, what do you think is the issue with this? Like, if you read the problem, you're given that the size of the string is divisible by K. In your case, the string size is not divisible by K. So that's it. Thanks for joining.